Welcome to today's session. In our today's session, we are going to discuss another type of single stage mass amplifier, that is common drain amplifier. Okay, it is usually called as or popularly called as source follower. So just like emitter follower we have seen in BJT, here we are having a source follower in the MOSFET. Okay, so it is a straightforward and simple amplifier, which is where we are having a common drain. That is, drain terminal is common between input and the output. So the input side will be gate, output side is the source terminal, whatever it is going to be connected. Now you just observe here, drain I have connected without using any drain resistance. Okay, just to make this signal to be ground, there is no need of connecting the source resistance, so resistance is removed from this part. Okay. So from the input side, the input signal V signal that is going to be coupled through this capacitor CC1 at the gate terminal. The output voltage obtained from the MOSFET analysis is coupled through the capacitor C2 and it is obtained at the terminal V0 through the load resistor. Okay. So again, this is a general basic structure using a constant current source. Okay. So this is a circuit diagram and its small signal equivalent model. We are going to consider an T model as we have done it for common source amplifier with source resistance. You just observe, we are making use of channel length modulation, that is finite output resistance. We are making use of it R0. It is connected across the small signal equivalent of the MOSFET. Small signal equivalent of the MOSFET. Are you able to see this? Right? Now you can observe remaining all are same. At the input side, I am having the V signal, R signal, the coupling capacitor is shorted, RG is available. This particular is MOSFET's small signal equivalent model, and this is because of channel length modulation. Now you just observe, this is most important one. Now the output is connected across this source terminal. You can just observe this constant current source. Because of presence of this load resistor, it creates an low resistance path, due to which this becomes an open circuited. Which is appeared as an open circuit in the small signal equivalent model. You can observe there is no effect of current source. Source is connected, terminal is connected through this coupling capacitor to the load resistor. Just observe, source connected to the load resistor, connected across an terminal output voltage V0. Therefore, across this resistance 1 by Gm R0 and RL, I am going to have the input voltage Vi. Okay, so this will be clear while we are going to analyze this. Let us start analysis. At the input side, you can observe Rin is equals to Rg. So this is we know this thing. Right, at Vi, if I am applying potential divider path, it is V signal Rg by Rg plus R signal. So approximately equal to V signal. Why I have written this is, you know the condition, Rg is very much greater than R signal. If it is very, very high, this to get cancels, I am going to get Vi is equals to V signal. Okay, this is also clear. Now at the output side, I am going to find, as I told, Vi is the voltage across this 1 by Gm, RL and R0 resistor. You just observe, this is a terminal where I am having V0 voltage. This is grounded. Now in the small signal analysis, the drain is common. It is grounded. Okay. So therefore, R0 gets parallel to RL. R0 becomes parallel to RL. So this combination is in series with 1 by Gm. Therefore, at this terminal, if I want to write equation for V0, I am using potential divider path, where at this terminal Vi is going to come, which is nothing but Vi, grounded resistance is R0 parallel to RL, divided by R0 parallel to RL plus 1 by Gm. Right? I hope it is clear. At this terminal, V0 potential divider path, V0 is equal, this is very important here, V0 is equals to grounded resistance R0 parallel to RL divided by total resistance R0 parallel to RL plus 1 by Gm. Okay, so this gives you the output voltage. Now from this output voltage, I am going to find voltage gain, which is nothing but output by input voltage. Output voltage is V0, input voltage is Vi. V0 by Vi. Just observe, V naught by V, I just take this terminology to this denominator. Now V naught by V is nothing but voltage gain. Its formula is R naught parallel to RL divided by R naught parallel to RL plus 1 by GM, right? Now this is your voltage gain. Now if you consider our open circuited voltage gain, we have discussed, we are going to remove the load resistor. I removed the load resistor. Just observe, RL is removed, R naught by R naught plus 1 by GM. Now this is very important expression to prove that it is a source follower. Now just observe, if I say R naught is greater than 1 by GM, I am eliminating this 1 by GM is to get cancelled, you will get 1. Approximately equal to 1, but not equal to 1, it will be always less than 1. Approximately equal to 1, when gain is approximately equal to 1, straight away I am speaking, at this source terminal, output follows the input. Therefore, this is also called as a source follower. Just like emitter follower, we have got the concept of source follower. Since the gain is unity, almost equal to unity, it is also called as a source follower because of condition R naught greater than 1 by GM. Okay, R naught greater than 1 by GM. Now in the equation of voltage gain, if you consider R naught is greater than RL, since it is a parallel resistance, R naught will also be eliminated. You will get RL by RL plus 1 by GM. Now we know that RL is greater than 1 by GM. Therefore again if we cancel it, the gain is becoming 1. So hence it is called as a source follower. Okay. So overall voltage gain, if you are going to consider, it is V naught by V signal. You take the V naught expression, V signal expression. If you are going to cancel whatever terminologies are there, you are going to get Rg by Rg plus R signal, R naught parallel to RL, R naught parallel to RL plus 1 by GM. This is overall gain of the common drain amplifier. So now from the output side, if you are going to see, we will see only two resistances, R naught and 1 by GM. So now expression for output resistance is R naught parallel to 1 by GM. So R naught parallel to 1 by GM. Now as R naught is greater than 1 by GM, from the conditions, I can straight away write R out as approximately equal to 1 by GM. Right? So this is a simple and straightforward approach wherein analysis becomes very easy for us. So I hope you have understood how to get voltage gain, how to get input resistance, output resistance. Overall, I can say that for common drain amplifier, input resistance is high, output resistance is low, and gain is almost equal to 1 but not equal to 1, exactly equal to 1. Right? I hope you have understood this concept. In the next session, we will continue with the next topic. Thank you.